This is Jacob's Algebra, Chapter 11, Lesson 1, Part 2. So we finished up with number 7, which was just like number 19 that I assigned for homework. Actually, no, that was just like number 18 that I assigned for homework. So now we're going to start with number 8. Number 8 says reduce each of the following fractions to lowest terms. So we're going to do just a couple of these as examples. Part C is 15 over 51. Now, if you remember your divisibility rules, you know any number is a multiple of 2 if it ends with an even number. Any number is a multiple of 3 if the sum of its digits is a multiple of 3. Any number is a multiple of 5 if it ends with a 5 or a 0. And then any number is a multiple of 9 if the sum of its digits is a multiple of 9. So, when we look at 15 51st, 15, 1 plus 5 is 6. Well, 51, 1 plus 5 is 6. So that means that both the numerator and the denominator are factors of 3. Are multiples of 3. So we can write 15 as 3 times 5, and we can write 51 as 3 times 17. If we divide the numerator and denominator by 3, we will end up with 5/17. So that is the lowest term that we can reduce 15 51st to, because 5 and 17 are both prime numbers. Okay, part D is 51 15ths. Well, that's easy because we just found that they're both multiples of 3. So 51 15ths reduces to 17 fifths. Okay, part E, we have 33 over 303. Well, this one's really easy to see that both the numerator and the denominator are multiples of 3. So 33 is 3 times 11. 303 is 3 times 101. Divide the numerator and the denominator by 3, and we end up with 11 101ths. And then part F, we have 33 over 3003. Again, easy to see that these are both multiples of 3. 33 is 3 times 11. 3003 is 3 times 1001. Divide the numerator and denominator by 3, and we get 11 over 1001. And I'm going to work just one more to get something that is not a multiple of 3. So we're going to do, actually this is part B, 8/12. You can see the numerator and the denominator are both multiples of 2 because they're both even numbers. In fact, they're both multiples of 4. 8 can be written as 4 times 2. 12 can be written as 4 times 3. Divide the numerator and denominator by 4, and we end up with 2/3. So that was number 8, which is just like number 19 that I assigned as homework. So let's move on now to number 9. Number 9 is change the following sets of fractions to fractions that have the same denominator. Now, it does not say to the least common multiple denominator. So, worst case scenario, you multiply all your denominators. So, if you have part B, which is 3/7 and 7/3, there are the least common multiple of 7 and 3 is 21. So, I'm going to write both of these as fractions of 21. To get from 7 to 21, I had to multiply by 3. So for the numerator, I need to multiply by 3. 3 times 3 is 9. To get from 3 to 21, I had to multiply by 7. So I need to multiply our numerator by 7. 7 times 7 is 49. So our new fractions for 9b are 9/21 and 49/21. That is writing both numbers, that's writing the set of fractions to fractions that have the same denominator. Okay, part C. I have 1/24 and I have 1/36. Now, I happen to know that 72 is the least common multiple for both of these. But even if I did not know that, I could just multiply 24 times 36 and use that as my common denominator. 24 has to be multiplied by 3 to get 72. So we're going to multiply our numerator by 3 and have 3 72s. 36 has to be multiplied by 2 to get 72. So we will multiply our numerator by 2 and get 2 72s, or 70 seconds. So our set of fractions is 3 70-seconds and 2 70-seconds. Okay, let's get a new page and we will work just a couple more of these. Let's look at 9E. We have 1/3, 1/4, and 1/5. Okay, I need to spread these out some. 1/3, 1/4, 1/5. Okay, what is our best choice for this? Well, we can go, usually what you want to do is take your largest denominator and start counting by that denominator until you find something that will, that is a multiple of your other denominators. In this case, since 3 and 5 are both prime numbers, I know that I can go ahead and multiply those to get 15. And then multiply it by 4 to get 60, and I'm not going to have anything less than that. That's a common denominator for all of them, a common multiple for all of them. So I'm going to write all of these as fractions of 60. To get from 3 to 60, I have to multiply by 20. So that means I need to multiply our numerator by 20. To get from 4 to 60, I have to multiply by 15, which means our numerator needs to be multiplied by 15. To get from 5 to 60, I have to multiply by 12, so we're going to multiply our numerator by 12. And so our fractions we end up with are 20 60ths, 15 60ths, and 12 60ths. Okay, the last one we're going to do from number 9 is part F. Part F is 3/4, 7/8, and 15 16ths. Now, if you look at these, 16 is a multiple of 4 and a multiple of 8. That means we don't have to do anything to this. We can write everything as a fraction of 16. To go from 3/4 to some number of 16ths, what do I have to do? Well, I have to multiply 4 by 4 to get 16. That means we need to multiply our numerator by 4. 3 times 4 is 12. Okay, 7/8 as a fraction of 16. To get from 8 to 16, I have to multiply by 2. So I'm going to multiply my numerator by 2. 7 times 2 is 14. So my set of fractions is 12 16ths, 14 16ths, and 15 16ths. So that was number 9, which is just like number 20 that I assigned as homework. Okay, next one we're going to look at is number 10. Arrange the following sets of fractions in order of increasing size. Okay, the two rules for this, you want to get everything with a common denominator. You need to have either a common denominator or a common numerator to be able to determine whether the fractions, to be able to compare the fraction size. So for part A, they give you 3/7, 2/7, and 4/7. And since all of our pieces are the same size, they're all 7ths, we can tell that 2/7 is the smallest, 3/7 is the next one, and then 4/7 is going to be our biggest one. So we would write them 2/7, 3/7, 4/7 as our answer. For part B, we're given 7/3, 7/2, and 7/4. Now here we have a common numerator, but our denominators are all different. So since we have the same number of pieces, because the numerator tells you how many pieces you have, the denominator tells you the size of your pieces, we know that halves are the biggest pieces, fourths are our smallest pieces. So 7/2 is going to be our big, whoops, we want to write these from smallest to largest. So our smallest amount is going to be 7/4 because we have 7 of it, but it's our smallest pieces. And then 7/3, and then our biggest one is going to be 7/2. So we would write our answer 7/4, 7/3, 7/2. Okay, and then I'm going to do just one more example. That's going to be part C, where we have 1/3, 3/10, and 11/30. Okay, these all have different denominators and different numerators, so we have to actually put these in common terms. Our least common multiple is 30, and we already have one as a fraction of 30, so we're just going to convert these other two to equivalent fractions. To get from 3 to 30, we had to multiply by 10, so I'm going to multiply our numerator by 10, and we have 10/30. To get from 10 to 30, we had to multiply by 3, so I'm going to multiply our numerator by 3. 3 times 3 is 9. So we can see here easily that our smallest fraction is 9/30ths, our next biggest fraction is 10/30ths, and then our largest fraction is 11/30ths. So we would write our answer as 3/10, 1/3, and then 11/30ths, because that is the ordering from smallest to largest. Increasing size means you start with the smallest and move up to the largest. Okay, so that was number 10, which is just like number 21. Now we're moving on to number 11. Number 11 says, which fraction in each of the following sets is not equal to the others? In this case, all of your fractions are the same. You have the same number on top, you have the same number on bottom. What you have to see is, are they all the same sign? So looking at 11a, we have -3 over -7. That's positive, because negative divided by negative is a positive. The next one we have is 3/7. Positive divided by positive, that's a positive. The last one we have is -3/7. That's negative. Which one is not like the others? The negative one. So our answer for 11a would be -3/7. I'm going to do just one more, part D. For part D, we have negative of -4/9. We have 4 over -9. And then we have negative of 4 over -9. So looking at this first fraction, we have a negative of a negative. That gives us a positive. Second fraction, we have a positive divided by a negative. That's a negative. The last one, we have a negative of a negative, and that gives us a positive. So the one that's different is the one that's in the middle. So 4 over -9 is going to be the one that's not equal to the others. So that's all that you're doing in number 11, is checking to see what the signs are. Remember, 2 negatives make a positive. 3 negatives make a negative. So that was number 11, which is just like number 22 that I assigned. Okay, let's move on to number 12. Number 12 says, if possible, express each of the following fractions as an integer. So for part A, we have 8 plus 4 over 8 minus 4. Well, 8 plus 4 is 12. 8 minus 4 is 4. 12 divided by 4 is 3. Okay, move on to part B. We have 5 minus 5 over 5 plus 5. Well, 5 minus 5 is 0. 5 plus 5 is 10. 0 divided by 10 is 0. Part C, we have 3 plus 9 over 3 minus 9. 3 plus 9 is 12. 3 minus 9 is -6. 12 divided by -6 is a -2. And then we have part D, 2 plus 2 over 2 minus 2. 2 plus 2 is 4. 2 minus 2 is 0. We can't actually do this. This is undefined because we cannot divide by 0. So you can write undefined, or you can write not possible, because it says, if possible, express the fraction as an integer. This is not possible to write as a fraction, as an integer, because it's undefined. So that was number 12, which is just like number 23. Okay, so next we're going to look at number 13. Sorry, whoa, that reset. Hold on. Let me find that page again. Let's get a new page. We're going to look at number 13. It says, find the values of the following expressions for the values of x indicated. So we have two expressions here. We have 10 plus x divided by 2 plus x. And then we have 10x over 2x. And then we're going to check this for different values of x. X equals 2, x equals 6, x equals 0, x equals -1, and x equals -3. So when x equals 2, we have 10 plus 2 is 12, divided by 2 plus 2 is 4, we get 3. Now I'm going to put 6 in the same equation. 10 plus 6 is 16, 2 plus 6 is 8, 16 divided by 8 is 2. Now I'll plug in 0. 10 plus 0 is 10. 2 plus 0 is 2. 10 divided by 2 is 5. Now I'll plug in -1. 10 minus 1 is 9. 2 minus 1 is 1. We get a 9. And then with -3, 10 minus 3 is 7. 2 minus 3 is -1. We get -7. Now we try plugging this into our other equation. Looks like we're going to have a part 3. I'm going to go ahead and stop the video here, and I will finish this on part 3